Hi everyone, my name is Dmitry Kostikov and I'm going to tell you about creation of production-ready Kubernetes cluster. Please send plus message to our chat if you can hear me well. You can see my screen share. Okay, thank you. Okay, so while we are waiting for other joiners, let me tell you why I decided to talk on this very topic. So actually, it's quite easy to create a Kubernetes cluster in Azure. It's just a matter of 4 clicks. You click create. Then there are some presets, and you can choose like production economy, production and
or the reverse managers from those, so you can query across multiple tables simultaneously. If GraphQL has this big scaling problem, why do we care at all?
uh, Uh, s- uh, actually, yeah, you can use different approaches. I use the user interface just to demonstrate the functionality. Of course, I wouldn't recommend to use it for your production environment. In production environments, it's much better to use tools like CLI or Terraform. Okay, to so you can create a Kubernetes cluster just in a few clicks using presets. But I don't think that it's a really good approach because it's good for testing. But if we are talking about live environment, I think it's better to understand each of these parameters, understand the trade-offs, what's good, what's not really good. That's why I'm talking on this issue. Okay, so before we start, let me introduce myself. My name is Dmitry Kostikov. I work as a senior engineering manager at Stan International. I started my career as a C# engineer, and still I'm quite a technical guy. I work with a wide range of technologies. It starts in C#, Terraform, Azure, Kubernetes, and so on. And today we are going to cover the following topics: high availability, upgrades, node pool configuration, monitoring, and after all these topics, we will have a Q&A session. So feel free to post your questions to Q&A in your interface. Okay, so let's start. Uh, so I'll just go through all these parameters one by one, and sometimes we will go much deeper than just looking at the parameters. Okay, let's start. So first two parameters are region and availability zones. Let's firstly understand what region and what availability zone are in Azure. So in Azure, there are so-called regions. It's about geography. It can be US, Europe, and so on. And inside one geography, there can be several availability zones. For the most regions, there are 3 availability zones. For some of the regions, there are 2, or I believe there are some regions with only 1 availability zone. So availability zone, effectively, it's a isolated data center with independent power, independent internet. So if you distribute your resources between different availability zones, you increase your availability. Of course, it's more reliable to put your resources in different regions, but it's a much more complicated configuration, and actually it's out of scope our today talk. Because talking about Kubernetes, if you would like to spread your Kubernetes cluster between different regions, you would need just to create a different Kubernetes cluster. Now we're talking just about creation one Kubernetes cluster. Okay, so we have the parameter. We can choose a region, and we can choose availability zones. It's important to understand what are we choosing here. So as you can see, and actually it's stated in the documentation, this parameter applies to a control plane. So let's understand what is control plane. So Kubernetes consists of two main parts. It's control plane and nodes. If we're talking about managed Kubernetes, like Azure Kubernetes services, control plane is completely hidden from us. It's managed on Azure side, but we can choose should it be distributed by between multiple availability zones or not. So of course, it's good if you're talking about a live cluster. It's good to distribute the cluster between availability zones. But what about nodes? To configure multiple availability zones for nodes, we should go to nodes. And there is a similar availability zone configuration. So you can configure, you can choose one zone or multiple zones. Looks like we should choose we should always choose 3 zones, and that's it. But and it's true in most of the cases. But let's dive in a little bit into this topic. So you can, if you choose to use 3 availability zones for this particular node pool, your nodes or virtual machines would be distributed between 3 zones, and that's it. If you choose 2, they would be distributed between 2. But you may choose a slightly different configuration. You may choose to create 3 node pools and choose only one availability zone for each of these node pools. To understand why it can be beneficial for us, we should dive into Azure Kubernetes networking a little bit, and especially into outbound traffic. So there are effectively 4 options or how outbound traffic from Kubernetes can be configured in Azure. The first option, load balancer. The second and the third options are net gateways, effectively just managed or user-created, and the user-defined routing. We will cover today user-defined routing, and we'll focus on the first 2 options. And you don't have these options on your user interface at all. So if you use CLI to create Kubernetes, it would be outbound type option. So what's the difference? Let's go to Azure documentation. Actually, it's a documentation on outbound traffic in general, not especially Kubernetes. There is one type that is not recommended at all. There is one type that can't be used with Azure Kubernetes, and there are 2 types that are actually okay or best. And let's understand the difference. So if we use a load balancer, the port allocation would be static, and if we use net gateway, allocation would be dynamic. As you know, when we we need to connect some point in the internet from a private network, we need a so-called net translation, net address translation, and to do so, we need we need to allocate a port. So if we're talking about static allocation, let's say we have 1,000 virtual machines in our cluster. The total amount of available ports would be statically allocated between these 1,000 virtual machines. Even if only one machine uses outbound connection and all other machines don't, the allocation would be static, and each of these virtual machines would get the same number of ports. In case of dynamic, it wouldn't be the case, and the allocation would be done according to actual consumption. So if you have a high loaded cluster and a lot of ports goes to an internet, maybe it can be useful to use net gateway, not a load balancer. But there is a potential problem here. The problem is if the top configuration is service net gateway and the bottom configuration is load balancer. The configuration as load balancer looks much easier, and it's actually easier because load balancer is a multi-zone resource. So load balancer itself can be distributed between zones, and what you need to do is just to choose the standard load balancer tier. Is done by default in Kubernetes cluster, and it's that's it. It's multi. You have multi-zone availability for your load balancer. And we have a problem here with net gateway, because in Azure, net gateway is zone local resource. So if you have your multi-zone Kubernetes cluster and you have a virtual machine in different zones, then you connect all the node pool to a virtual network. Virtual network you connect to a net gateway, and the net gateway is zone local. It's always assigned to one zone. If this zone fails, your whole cluster loses an ability to connect to to make outbound connections, and that's the problem. To solve this problem, you may use that configuration when you create multiple node pools and assign a node pool, one node pool to a one zone. Then you create a dedicated virtual network for each node pool and dedicated net gateway associated with this very zone. And in this case, you would get a multi-zone available Kubernetes cluster. So just to wrap up, I think we should always use multiple zones for control plane. In most cases, load balancer is the best option because it's easy to configure. But in some high-loaded configuration, you would need to use net. In this case, it's better to use a strategy one network and one net gateway per zone. Okay, maybe it would be better to have questions after each block. So if you have some questions, feel free to ask, and I'll try to answer. Okay, don't see any questions yet. Let's go further. So, the next option would be the Kubernetes version. No. The next version is pricing tier. You can choose a free pricing tier. If you choose free pricing tier, it means that you pay only for virtual machines, for nodes. And that's not true that you can't create more than 10 nodes here. Actually, it's just a recommendation, and the maximum number, I believe, it's 100. But of course, for live environment, that's not the best option. And you should choose standard. And if you have multi-zone configuration, it would be 3.5 pipes. Okay, let's go to versions. In general, we have a patch version here and a minor version here. I always prefer to use, I recommend to use the last version, and I'll explain in a minute why we should do so. Let's look at the Kubernetes versions lifecycle. So if we're talking about Kubernetes community support, Kubernetes community supports the current version and 2 previous versions, and it supports a version for 1 year only. Azure Kubernetes has slightly different policy. It supports 3 versions that can be a little bit better for us. And actually, they used to have 1 year policy. Now they're going to introduce a 2-year policy, so they're going to introduce LTS versions. But still, we need to upgrade our Kubernetes cluster from time to time, so it's better to start with the maximum version. Of course, if we're talking about production, I wouldn't recommend you to use preview. The next option is automatic upgrades. And once again, okay, let's understand what can be automatically upgraded in Kubernetes. So there are 3 elements. The first element is Kubernetes itself, control plane, then node pools, and node images. Actually, it's OS images. And it's hard to control all these 3 elements with 1 parameter. And it's once again, it's a case when we don't have all the parameters on the user interface. Effectively, we have, if you use CLI, we have 2 different parameters: auto upgrade channel, that controls the upgrade of Kubernetes and node pools, and node OS that upgrades, that controls the OS images. The easiest way to explain that, these parameters, is just to go to Azure documentation. Okay, so let's start with Kubernetes cluster and node pools. The last option is about OS images. We wouldn't cover it right now because it would be controlled with another parameter. These 2 parameters, stable and rapid, would upgrade your minor version automatically. And I would never recommend you to do so, because it's high likely that your cluster would be broken after upgrading a minor version. We did it a few times, and every time our cluster was broken, some problems arise. And of course, we did it in our test environment and only then upgraded live. So for live cluster is just not an option, to my opinion. Then we have two other parameters, known and patch. And I think we have upsides and downsides of each parameters. If we choose known, we should have some strict procedures in place to always keep our cluster upgraded manually, because it's quite an often case when there is a security patch. And of course, it's not very good to run a cluster with security vulnerabilities. But if you have procedures in place, if you notify that the new patch released, then upgrade your test cluster and only then upgrade your live environment, I think it's a little bit safer than automatically upgrade the live. But in this case, you have some risk that you would lose important security update. And so automatic patching can be beneficial as well. Okay, let's talk about the second parameter, node OS upgrade, that controls the upgrade of an operation system image. There are a few options, and actually these upgrades happens much more frequently, and normal cadence is once a week, while the Kubernetes upgrades like 10 times a year, 5-10 times. Okay, so here we have option known. For me, it doesn't look a really good option, because these updates, OS image updates, are released very, very often, weekly, and it's hard to do everything manually. The second option is unmanaged. In this case, you just rely on operation system upgrades. But I wouldn't recommend this option, because it's really hard to control and monitor was the upgrade successful or not, how to configure maintenance windows, and so on. I think the best options is to not to rely on OS upgrades, but to use Kubernetes functionality to do that. And here we have two options, node image and security patch. Node image, it would apply security fixes and bug fixes, and the security patch would apply only security fixes. But at the moment, security patch is in preview, and I would not recommend to use any previews in a live environment. Sorry. So I would recommend to use here node image. Yeah. Let's. Any questions here? Okay. So let's go further. The next parameter, authentication and authorization. There are three options. The first, local accounts with Kubernetes, airbag. If you choose this option, you would need to create all your users inside Kubernetes. So you would effectively duplicate users. You would need to have all the users in Azure and in Kubernetes in most configurations. I don't think that it's a good configuration. It's a good approach to duplicate users. I think it's much better to use Azure ID authentication. And the difference between these two options is authorization, is airbag. So let's look at the differences. If you use the second option, you would create roles with standard Kubernetes syntax like that. And then you need just associate this role with some Azure Active Directory group. If you use the third option, you would define a role in Azure Active Directory syntax. I think, and actually it's quite a new approach, the third option. And I think it's much better to use the second option, to use Kubernetes airbag. You would find much more information on the internet about that. It's a standard approach. You can use the same approach in with any of Kubernetes, not managed Kubernetes, on-premises Kubernetes, Google Kubernetes, and so on. Okay, let's go further. Let's go to node pools. If we're talking about a live cluster, it's a good approach to use dedicated pools for system pods and user pods to ensure that system pods would never be affected by your workload. System pods can be like DNS and so on. So let's look at the node pool configuration. So the first option we already covered here, use our system, operation system, Windows, Kubernetes works in Azure, but my personal experience, in general, it's like a nightmare, frankly speaking. Okay, we already covered availability zones, and let's go to our node size. By default, we don't have this parameter on user interface as well. By default, the ephemeral disks would be created. Ephemeral disk means that it's a disk local to the CPU. It's an SSD local disk. The downside of this disk that information wouldn't be persisted between virtual machine restarts. And but for our purposes, to just put our operational system here, it's absolutely fine. But we should be aware that this disk is actually this temporary storage. And if you choose the size of a virtual machine with a small temp storage, you wouldn't be able to fit or an OS image here. So you should consider that when you're choosing images. The second point when you're choosing a virtual machine size is overhead. If you choose a virtual machine with, say, 2 cores, it would be really inefficient. For example, in our configuration, about 1 core and 1 gigabyte of memory is consumed by daemon sets and other system consumers. So you would lose like 1/2 of computing power and memory. That's why it's beneficial to use as big virtual machine as possible. On the other side, if you choose to use too small virtual machine, you would too big virtual machine. It may be the case when all the pods would sit on one node, and that's not good for high availability. So there should be a balance between two of these. Okay, then let's go to scaling method. Actually, there are 2 autoscalers in Kubernetes. The first autoscaler would add nodes to your node pool based on requests. You define the requests in your deployment, and if there are no resources to satisfy these requests, new nodes would be added automatically. The second is called horizontal autoscaler that would horizontally scale your pod. So this option is about the first one. It's not about horizontal autoscaler that scales the number of pods. And it's a good option to use autoscaler. It's very convenient. You just add new pods and nodes would be added automatically. For the minimum node counts, I think we should use 3 because we have 3 availability zones and we would spread all the workload between them. Or maybe even 6 for live environment. And the maximum it's just about costs. I don't think that it's in general it's a good option to use a public IP per node. Okay, let's go further. So the next configuration is about networking. First option is our private access. This is about API server only. So if I uncheck this option, my API server would be available in a public internet. Yes, I can do some whitelisting, but for production clusters, I don't think that we should expose this to public internet at all. So if I choose this option, well, the API server would be available only through VPN or solutions like that, and I wouldn't be able to use kube control from my laptop directly. I would not cover the next 2 options because it would take us like 30 minutes to cover or even more to cover only these 2 options. But I would give you a link to a great explanation of the Kubernetes networking. It would be in the presentation, and you can just watch this great video. The next option I'm going to cover is network policy. Network policy is a tool that can restrict an access from one port to another. The problem with this option is you wouldn't be able to change this option in future. If you don't plan to do it right now, you can choose no, but then you wouldn't be able to change this. You would need to create a new Kubernetes cluster and do a migration that can be quite costly. That's why I think it's a good idea to choose one of these options. Frankly speaking, I don't have on-hands experience with this. But I know that Azure is just a new functionality. They released it maybe a year ago or less, and Calico is quite a mature solution, and I prefer to use this option for my cluster. Okay, let's go to integrations. Here, the first option is about container registry. It's good if you are going to use Azure container registry, it would be very, very convenient to choose here the container registry, okay, or create one. Because in this case, all the authentication issues would be solved for you, and your Kubernetes cluster would be able to pull your private images from container registry just out of box. The next options are about login, about monitoring in general. So let me click custom configuration. And And here I can see three different options. First option is Container Insights. Container Insights is a Microsoft solution that can be used for some performance monitoring, but the main purpose, the main use case for me of the Container Insights is logging. Let me show you how it looks like. So there are some performance information, but I don't think that it's really useful. The really useful functionality is storage of Kubernetes logs. So here I'm just querying the logs of some container. Effectively, these logs are the same logs that you can get by kube control logs, but the difference is that these logs are very persistent. And if you had some troubles with one of your containers yesterday or a few weeks ago, you can always dive into these logs and get the required information. These two options are about Kubernetes and Grafana. I think it's the best way to monitor your cluster. If I choose these two options and create a Kubernetes cluster, the standard dashboard will be created for me, and we can benefit of this great standard dashboards to monitor Kubernetes. Okay, so the next option is about alerting. We can use Grafana functionality, Grafana alerting functionality, or we can use Azure functionality to do that. Actually, I think if you're familiar with Grafana, it would be beneficial for you to use just this option and not to use this option at all. If you have already some alerts in place for other sources, it can be beneficial to use these alerts. The next option is Azure policy. It can be useful because if you enable this option, you would be able to see some security recommendation how to adjust configuration in your cluster. So I recommend to enable this. And the last step, enable secret store CSI driver. This driver would help you to map your Azure Key Vault to a virtual drive, and then you would be able to connect this virtual drive to any of your pods. And for example, you can put your SSL certificate to Azure Key Vault, and then with this option, the drive. With this option, you can connect some of the pods that need this certificate to this drive, and the certificate would be available for that. So I think it's a good approach to handle such secrets because they would be available to both Azure resources and Kubernetes resources. So actually, that's all from my side today. And let's start an Q&A session. Any questions? Okay. Looks like we don't have any questions today. So thank you all for joining, and have a nice evening.